Welcome to another edition of You and Me and Multiple Sclerosis. My name is Pam, and I've been living with multiple sclerosis for over 37 years. And if you watched my last video, I talked about BTK inhibitors as possibly, just possibly, providing a cure for multiple sclerosis. And that's pretty exciting news, right? But you know what would be even more exciting? Would be some way to prevent getting multiple sclerosis in the first place. Today, we may have the knowledge that we need to actually find a way to cure multiple sclerosis, but it may be too early to say. But I want to share that with you. It's probably something you've heard about if you've been following the state of MS research at all. And that has to do with the Epstein-Barr virus and its possible role as a causal agent, if not the causal agent, in the development of multiple sclerosis. Now, this is not a new idea. At least since the mid-2000s, researchers have been talking about Epstein-Barr's role in the development of multiple sclerosis, notably Dr. Gavin Giovannoni, and I've talked about him quite frequently. And I should pause here just to say that, like other viruses, such as herpes, Epstein-Barr virus, once a person contracts it, even when the symptoms disappear and the person has technically recovered from the virus still lives in the system forever, for the rest of your life, and often not really causing any trouble, but there it is. And so for someone with multiple sclerosis, that living virus in your system might be doing some damage under the surface that we aren't aware of. The big breakthrough came with a paper that was published just after the beginning of 2022. January 13th, a paper appeared in the journal Science that discussed an absolutely huge study that was done of people that were in the military. The sample size was way bigger than you would need to show that you had enough participants in the study to give you confidence in the results. And the other aspect of it is that the military tracks everything. They take blood samples when a person is first inducted, and then again at some period of time after that. And so there's a lot more documentation on these individuals than one would normally see in the population. Well, let's go ahead and take a little look at some of the findings that this paper discusses. Epstein-Barr does seem to have a big role to play in the development of multiple sclerosis. Here's the study that's publicly available, and I will put the link in the description so you can read it for yourself. It just took the MS world by storm when it came out on January 13th of this year, 2022, as you can see here. And it was titled Longitudinal Analysis Reveals High Prevalence of Epstein-Barr Virus Associated with Multiple Sclerosis. And as you can see here, the major researchers in this study were from Harvard University. Now, I'm not going to read this whole paper to you, although I recommend that you go out and look at the whole thing yourself because there's a lot in here. But here's the abstract. Multiple sclerosis is a chronic inflammatory demyelinating disease of the central nervous system of unknown etiology. So in other words, we don't really know the cause. We tested the hypothesis that MS is caused by Epstein-Barr virus in a cohort comprising more than 10 million young adults on active duty in the U.S. military, 955 of whom were diagnosed with MS during their period of service. Risk of MS increased 32-fold after infection with EBV, but was not increased after infection with other viruses, including the similarly transmitted cytomegalovirus. Serum levels of neurofilament light chain, a biomarker of neuroaxonal degeneration, increased only after EBV seroconversion. These findings cannot be explained by any known risk factor for MS and suggest EBV as the leading cause of MS. And I know there were quite a few words in there that you might not be that familiar with, but I think you get the gist. The experimental variables were tested, controlled for, all in service of making sure that the conclusions could not be explained away by other things. And we'll go ahead and look at some of that and talk about it. I'm going to shift over here for a moment to another video that I will link down below. Ask an MS expert the role of Epstein-Barr virus in multiple sclerosis. And the reason that I'm putting this one in here is that Dr. Bruce Bebo, who's being interviewed in this video, lays out for us the rules, basically, that would help us know whether the conclusions of the experiment that's under consideration can be trusted. And as you can see here, to show that EBV causes multiple sclerosis, it must be established that, and there's 4 things. Number 1, that EBV infection comes before MS. Well, quite obviously, it wouldn't do any good to say that there was a causal relationship if you saw that somebody had been diagnosed with multiple sclerosis before they were infected with EBV. So that has to be ruled out. The second thing is possible confounding factors have been identified and eliminated. So just because something happens after something else doesn't mean that that second thing was caused by that first thing. The old example that's often used is that violent crime tends to go up when ice cream sales go up. But there's a confounding factor there, right? The hot weather. The hot weather accounts for both the sales of ice cream and the increase in violent crime. So that has to be eliminated in this case. If there's some other reason why a person might be more susceptible to both EBV and multiple sclerosis, we need to identify that. Well, one thing we do know about EBV, by the way, is that it is incredibly prevalent in the population at large. At least 95% of people end up having EBV, usually fairly early on in life. So that can't really be seen as a confounding factor, but it all had to be looked at. And then the third item is that we need to ensure that reverse causality isn't a possibility. So in other words, because I am more likely to develop MS, does that make me more likely to develop Epstein-Barr? So it really could go the other way, right? It could be whatever genetic component I have that makes me susceptible to MS, that same genetic component might make me more susceptible to EBV. And so that has to be eliminated as a possibility. And then finally, we need to demonstrate that preventing Epstein-Barr infection also prevents MS. And that's kind of the holy grail. That's what we're looking for. We're wanting to know if we stop people from getting Epstein-Barr, can we prevent them from getting MS? Well, we'll talk more about that, but you can clearly see where that would be an exciting development indeed. We're back to the science paper now, and here's what the authors have to say on that issue of causality. Causality implies that some individuals who developed MS after EBV infection would not have developed MS if they had not been infected with EBV. Ruling out a randomized trial, the gold standard to study this counterfactual occurrence is an experiment of nature, a longitudinal investigation of MS incidence in a cohort of EBV negative individuals, some of whom will be infected with EBV during the follow-up and some who will not. The ubiquitous nature of Epstein-Barr virus, which infects about 95% of adults, and the fact that MS is a relatively rare disease has until now impeded such an investigation. Over the course of a 20-year collaboration with the U.S. military, we have identified cases of MS in a cohort composed of active duty U.S. military personnel between 1993 and 2013, a racially diverse population of over 10 million individuals. Only one of the 801 MS cases occurred in an individual who was EBV negative in the last sample, which was collected at a median of 1 year before MS onset. At baseline, 35 MS cases and 107 controls were EBV negative. All but one of these 35 EBV negative MS cases became infected with EBV during the follow-up, and all seroconverted before the onset of MS. And seroconversion refers to whether the antibodies to EBV are present in the bloodstream. The researchers say a causal interpretation of our results requires ruling out the possibility that systematic differences between individuals who seroconverted and those who remained EBV negative explain the results. These differences can be grouped into two categories. 1, confounding by known or unknown factors, and 2, reverse causation. Confounding by known factors is virtually ruled out by the strength of the association. To explain a 32-fold increase in MS risk, any confounder would have to confer a greater than 60-fold increase in risk of EBV seroconversion and a greater than 60-fold risk of MS. None of the known or suspected risk factors for MS has such a strong association. And then jumping down further in the paragraph, the existence of a still unknown factor that increases the risk of both EBV infection and MS by greater than 60-fold is rather implausible, and there are no good candidates, even hypothetical ones. This conclusion would be robust even in the very unlikely case that EBV seroconversion in one of the MS cases was a false positive result, in which case EBV infection would confer a 16-fold increase in MS risk. And then they address the topic of reverse causation. They said that it could occur if the immune dysregulation during the preclinical phase of MS increases the susceptibility to EBV infection. In our agnostic search of the entire human virome during the preclinical phase of MS, we did not find other systematic differences in the antibody response to any pathogen except Epstein-Barr that was related to previous infections in multiple sclerosis cases and controls, which makes it unlikely that the immune dysregulation during this phase increases susceptibility to infection. One MS case that was EBV negative in the last sample obtained 3 months before MS onset, which could suggest that EBV was not the cause of disease in this patient. This individual could have been infected with EBV after the last blood collection, could have failed to seroconvert in response to infection, which is an uncommon but nevertheless regular phenomenon seen after infections and vaccines, or could have been misdiagnosed. The extremely low MS risks in EBV negative individuals suggests that by far most MS cases are caused by EBV and could thus potentially be prevented by a suitable vaccine. The addition of MS to the list of diseases that an EBV vaccine could target strengthens the rationale to accelerate ongoing research with the primary goal of preventing infectious mononucleosis and post-transplantation lymphoproliferative disease. Those are two good reasons, in addition to MS, that an EBV vaccine would be very useful to prevent mono, and also there are certain cancers that could be prevented possibly if we had a vaccine against Epstein-Barr. In this paragraph, they're mainly talking about current therapies that are anti-CD20 monoclonal antibodies, and that there is, as those of you who are on some of those, like ocrelizumab, as you're aware, they do somewhat increase the risk of infections, and it would be really advantageous if we could have a vaccine that might prevent that from happening. And I just briefly wanted to look here at the funding sources for this research, because one of the major funders was the National Multiple Sclerosis Society. In particular, this organization funded the part of the study that looked at eliminating the confounding factors that we talked about a little bit earlier. Dr. Brandon Beaber has a good video on this that I will link down below. But I'm going to play just a little clip from that because he does a good job of explaining something that I found a little complicated at first. So hopefully you'll find this useful too. But it helps us understand some of the results in light of which came first, the chicken or the egg, and also shows you in a way how hard it might be to do clinical trials on anything related to this, because MS shows up when it shows up, and it might be years after the triggering event, as it were.
Another way to look at it, if you take everyone who tested negative for EBV at the beginning, who eventually got multiple sclerosis, how many of them converted to positive prior to the diagnosis? So EBV negative is represented by the green dot, the blue dot is EBV positive, and the orange dot is multiple sclerosis onset. And you can see sometimes people had like a 20-year delay from entering the military to getting multiple sclerosis. And if you look at the distance between the blue dot and the orange dot, from turning EBV positive to getting MS, it could easily be a 10-year delay or more. And obviously the blue dot is just when they were tested. They may have had the virus years earlier. The point is, out of the 35 people, 34 of them out of 35 converted to EBV positive first. There was just one person, you can see, who did not. And I would be very interested to know the clinical details of this one individual and if they really genuinely had multiple sclerosis and if the blood test was actually accurate.
So that's where things stand right now. There are clinical trials. They're looking at safety at this time. They're wanting to make sure that any vaccine that they come out with to stop us getting Epstein-Barr virus is safe. So they've been recruiting people without MS to do that test for them. But then it'll go on and there'll be other trials. There may be opportunities to be involved in that. So keep a watch on clinicaltrials.gov if you're interested. I'm curious to see how they're going to be able to do clinical trials, given that MS takes a long time to show up, sometimes years and years after the triggering event. So we'll have to see what the scientific community comes up with. But it's pretty exciting, and I'm glad to see that early research and early speculation on Epstein-Barr seems to be bearing some fruit, and that we might actually be able to find a relatively simple way to keep people from ever having to deal with multiple sclerosis. And for those of us who've had it for many years and have accepted it as a part of our lives, this all may not really make that much difference for us. It may prevent further damage if we've already got an immune system that's pretty well messed up. If we're already missing axons, if we've already got a lot of demyelination, it's not going to send us back to the days before we had any MS. But it may stop it from getting any worse, and I wouldn't mind that, and I'm sure you wouldn't either. Well, that's all I had for you today. Thank you for watching. Take very good care of yourself, and I will see you again in my next video.